Well, dear friends, now I start new chapter in this video, kinetic theory of gases. Kinetic is motion. Actually, the properties of gases are studied by studying the motion of molecules of gas, and that is why the name of chapter is kinetic of gases. Different gases have different chemical properties, but at low pressure, high temperature, all gases represent almost same physical properties. They exert pressure, etc. So we will try to know, although there are some things which are different, but many things are same. So to study this, first of all, I will tell you some fundamental laws of gases. The first one is Boyle's law, and we will consider the property of, we say, ideal gas or perfect gas. Perfect gas. People are very much confused about the concept of ideal gas. Actually, you have learned the model of solid liquid gas. In case of solid, atoms or molecules are closely packed by strong force of attraction. That is why they have their own shape and size, and they have fixed density, and they show shearing stress, and they show shearing. Now in case of liquid, the molecules are closed, but the molecules are weakly bound, and hence liquid when poured in containers may occupy the shape. So liquids have constant volume but no definite shape. In gases, gas molecules are very far apart. In one example, you can take the example of vapor and water. Volume of 1 kg vapor is nearly 10,000 times that of a volume occupied by 1 kg of water liquid. So gas molecules are very much far apart from each other as compared with the molecules of solids and liquids. So ideal gas is that in which force of attraction between molecules is zero. Ideal gas of perfect gas same. They talk about real gas. Real gas also has molecules far apart. There may be a weak force of attraction, and hence real gas get liquefied when temperature is decreased and then solidified. So these are some difference. But every gas at high temperature, low pressure, every real gas, I can say here, at high temperature and low pressure may behave like ideal gas. So now we will treat now every gas as ideal gas and learn some laws. First law of gas is Boyle's law. Boyle's law. Please, actually, if you study books, it becomes difficult. I spent 2 hours to study this chapter from the NCERT and another book, just to tell you, and I came to the conclusion that let me first tell the basic laws of gas. So Boyle's law, if here we have a gas, we have learned a lot of things about Boyle's law in the last chapter, high thermal change Boyle's law. If it is here a gas in the cylinder and it has a fixed mass of gas and a constant temperature, mass and temperature of gas are kept constant. If we decrease pressure, suppose here some weights are placed just to calculate the pressure of gas. If pressure decrease, volume get increased, and vice versa also. So what does Boyle's law state? According to this law, हो सकता है आप जानते हैं, according to this law, pressure P of a given mass of gas, at constant temperature is inversely proportional to its volume V. Pressure proportional to V. When mass of gas and temperature of gas kept same, like this, if the gas is filled with this container, fitted with airtight piston, then gas will not go out, so mass remains same. Actually, we will study the property of gas in terms of these parameters: pressure, temperature, mass, volume. And mathematically we can write P proportional to V, or PV equal to K, where K is constant of proportionality. K is constant of proportionality. K is constant of proportionality. Its value will depend on mass and temperature of gas. Value of K depend on mass and temperature, and therefore if pressure and volume of given mass at given temperature are changed from P1 V1 to P2 V2, then we can write the P1 V1 equal to P2 V2 equal to constant, same value आएगी, provided mass and temperature do not change. Or therefore, if we plot graph between pressure and volume of given mass of gas at constant temperature, so that curve come like this. It is volume, it is pressure. So the curve for ideally, suppose, and I have told this called isothermal at same temperature. Theoretically, practically you will get something different thing at a given temperature. I have told you PV graph at constant temperature is called isothermal curve. ये जो isothermal curve है that is from Boyle's law. Or one more graph here, if we plot the PV equal to constant. If I plot the graph between V and PV here, so what type of graph will be obtained? Ideally, it will be like this. मैं इसको मिला नहीं इसमें यहाँ पर क्यों? Because volume of gas cannot be zero. At any temperature, some fixed volume is there, straight line. You are well known about, I have discussed lot of things while teaching thermodynamics. So this is Boyle's law. So Boyle's law states that for given mass of gas, if pressure increases, volume decreases, or conversely, if volume increases, pressure decreases. By at this volume, pressure is this much, at this volume, pressure is this much, and so on. But once I asked question to a learned people, actually a very intelligent doctor was sitting with me, and he was very much interested in the education of their children. Now his daughter is also a doctor. I asked him, if we see Boyle's law, we find when volume increases, pressure decreases. But when we fill air in the tire of cycle or car or anything, their pressure and volume both increases. Why? When we fill air in a bladder, you can say, or any balloon, then volume and pressure both increases. While Boyle's law says that if volume increases, pressure decreases. So he was not easy in this giving the answer. He said temperature increase when we pump the gas. I said no, the gas is the bladder, the tube is inside a container maintained at same temperature. Actually, we never think about mass of gas. मैंने बार बार बोला mass and temperature are constant. So when we are filling air, we are increasing mass. So condition of Boyle's law is not obeyed. Boyle's law is for a given mass of gas. Every gas has some mass. Molecular mass of CO2 44. क्यों है? Because molecular mass is there. So I hope you have got my point. The Boyle's law applies only when temperature and mass are kept constant. Now I come to next Charles law. Charles law. Students, actually, lot of we people think that you are wise enough. Yesterday I was listening debate on TV why students and quota and in coach institute commit suicide. But all people talk round, गोल बातें करते हैं, सीधी बातें नहीं करते. Our evaluation system, awarding the marks, making the student pass, has become totally, I should say, false. We say students are not obedient in general. They don't come to school. The parent asks not attending classes. Why? If you are not obedient, even you don't have attended the classes, and teacher are giving full marks 20 out of 20. Practically in lab you have not attended any lab. You don't know anything about the lab, and you have been awarded 30 out of 30. At class, in the stage of class 11 and 12, you have to learn lot of things, dear students. Sit silently. Discover yourself. What do you know, what you don't know, which thing you understand easily, which you don't understand easily. But you have to work hard. When I listen so many, debates on TV, all are theoretical work. Ultimately, if you don't know what is also, yesterday I asked student class 10 what is median triangle. The two girls were there, none was able to define what is median, and they directly asked me, sir, what is centroid? If you don't know what is median, then how can you understand what is centroid? And even they know, they can't tell because they have never made a sentence. They have passed their exam by the following column, true, false, and fill up the blanks. So drafting ability has been destroyed. So you people, I request, if you like my video, please like and share. So now come to Charles' law. I again draw the same diagram. Here is a piston cylinder system, airtight cylinder and frictionless piston. And here we have kept some fixed weight on this. Now when we heat the gas, mass of gas fixed. And when we heat, we are increasing temperature. Pressure constant. So when pressure constant, we have learned a lot. In thermodynamics, volume increases. Then what is how states Charles' law? According to this law, volume V of a given mass of gas is directly proportional to the absolute temperature of gas. Absolute temperature means temperature taken on Kelvin scale, that is temperature taken on Kelvin scale. You know it very well now, but I am repeating again. So mathematically, V proportional to T, or V upon T is equal to K. Again here K is constant of proportionality. Again K is constant of proportionality. K is constant of proportionality. Whose value and its value depends on mass and pressure. of gas. So if something has been given in wrong information, please I am repeating. Volume of a given mass of gas at constant pressure. This volume of given mass at constant pressure directly proportional to temperature. So here pressure and mass are kept constant in case of statement of Charles law. Or from here we can write if volume and temperature of a given mass of gas at constant pressure are changed from V1 T1 to V2 T2, then we can write here क्या भाई कि V1 upon T1 is equal to V2 upon T2. And there is very important information here. If we plot a graph between volume and temperature of a given mass of gas at constant pressure, here temperature taken in degree centigrade, volume may be liter, may be meter cube. Liter is a big problem, right? 22 seconds. Volume 0, 100, 200, 300, minus 100, minus 200 and minus 300. 273 होगा यहाँ पर ये टेम्परेचर. The graph come like this. VT graph come like this only. We have produced it, and when we produce it backward, it meets here at minus 273.15 degree centigrade. At this temperature, volume becomes zero. So hypothetically, this temperature at which volume becomes zero is called as absolute zero temperature. So this is hypothetical because before reaching this, by gas law is obeyed, Charles law obeyed up to this. Here though it will not obey. At low temperature gas get liquefied and then solidified. But a concept is there. In next video I will take some more laws. Thank you.